Good afternoon, my YouTube viewers. It is Crystal here. Basically, I did a code review the other day for this person who needed help with his homework assignment. And basically, he's emailed me again, and he's been given some strange things to do with this homework assignment. And basically, I'm a self-taught machine learning engineer. I haven't taken any classes in the university or college or anything to learn machine learning other than the online courses that I've taken. So basically, what I've done is I've done the program in linear regression, which is what he asked, and then I sort of did it in the manner that this instructor asked to have it in. And it's not really a way that you would do it to make predictions, but I guess this instructor just wants to make sure that people are familiar with how to do machine learning. Since I've not taken a formal college course, I can't really say exactly what the procedure is other than what I've learned in the online courses I've taken. So I'll go ahead and go through this homework assignment the way that I personally would have done it. I'm not saying it's the right way, I'm just saying that it's the way I would have done it. And then it's also the instructor wanted it in linear regression. So the first thing we're going to do is on the California house prices data set. The California house prices data set is in Google Colab. So if you go here, you'll see it here. Maybe you'll see it. It says California housing test, California housing train. So you have to come over here and you have to copy path. And then when you copy path, that's actually how you get the train and the test data set. And then what we got on this particular one, we got the labels in both the train and the test data set. But if you were doing something like on Kaggle, then you wouldn't get the labels for the test data set. You would have to make predictions, and then those predictions would be the labels. So that's one thing that's different between Google Colab's California house prices and Kaggle's California house prices. So first thing that we're going to do is we're going to import our libraries. So we're going to import Pandas, NumPy, Matplotlib, Seaborn, and sklearn. So Pandas is used to make data frames and manipulate them. NumPy is for numerical calculations. Matplotlib is for visualization, where they take all of the data points and they plot them on a graph. And Seaborn is a more in-depth library written on the back of Matplotlib that enables you to visualize your data as well. And sklearn, which is not here, but it will be here in the program, is used to give the copious amounts of machine learning methods or functions to enable you to do machine learning. So after we have imported our libraries, what we're going to do is we're going to load the files, and then we're going to use the train and test files from the sample data set in Google Colab. So we've created the variable train with train equals pd.readcsv and the path of train. And then we've created the variable test, which is pd.readcsv, and then the path for test. And so what we've done is we've created the train and the test data frames, which are of the same format. So what I wanted to do is I wanted to take the train and the test and convert it to one file. And then as a result of that, I'm going to append test to train, and then this file that we have created is going to be called combi. So you've got some information on your data set. So this tells you what kind of data sets you have, and all of the columns are float 64s. Then we're going to check for null values. You do not have any null values in this data set, so that means that you do not have to impute anything, which is good. So we're going to drop the features. These are the features that the instructor asked to be dropped. He asked for longitude, latitude, and total bedrooms to be dropped. So because the longitude and latitude have been dropped, you won't be able to create a map using the longitude and the latitude. And I guess he decided to drop the total bedrooms as well. So now you've got, instead of the 9 columns that we originally had, you only have 6 columns now. So we're going to do a graphical analysis of median house price, and you can see around the $500,000 range, you've got a bunch of outliers there. So those outliers are going to affect the outcome of the outcome of the prediction. So what we're going to do is we're going to remove outliers, and we've got a whole lot of outliers that we removed, which is 1042. So what I'm going to do here is we just want to do a test to see how many outliers, if we take it instead of 1.5, we change it to 1. So let's see what happens to our outliers when we reduce it from 1.5 to 1. So that was 1.609. So let's say 1.5. And that's 1042. So it looks to me like you have less outliers with 1.5 than you have with 1. So that's something to take into consideration. So let's look over here and see what happens when we make it 2. Oh wow, and that's 0 outliers, so we can't do that. Let's make it 1.75 and see what happens. Wow. Let's make it 1.6 and see what happens. So it's 972 if you make it 1.6. So let's just leave it there for a little while. So we drop all of the rows that are in A. And so what they do is they take every outlier, every row that has an outlier in it, and they convert it to an NaN right here. So combi.log, combi x is less than or equal to min x, it's NPNaN. Combi.log, combi x is greater than max x, it's NPNaN. So we've got 972, which is less than what we previously had. And you can see that there's a difference between this outlier, this one, and this one. So what we've done is we have gotten rid of that big section of outliers. So we've created a correlation matrix, and when you create the correlation matrix, you get rid of some of the columns. But I had originally wanted to keep the latitude and the longitude in there because I wanted to be able to make a map, but I can't make the map now because the latitude and the longitude has been removed. So let's just see what happens if any of the features fall off when we have a correlation of greater than 90%. So that's 5 rows, and that's 6 rows. So we lost 1 column when we had a correlation of greater than 90%. So let me see if I can find out which row fell off. Households fell off. So we'll leave that there as a households being fallen off. And that can just show you that when you have features that have a very high correlation, you can remove some of the features, because if the features have a really high correlation, then they're going to be redundant, and then there's no point putting that particular feature in there. And that is especially true if you have a data set that has a lot of columns and you want to get rid of some of the columns. So now what we've done is we've done a scatter plot, and you can see the scatter plot here. We've done box plots, and you can see the box plots here are telling you the cost of the actual houses, and then it's also telling you that there are some outliers there as well. And now what we've done is we've done our heat map, and the heat map tells you the correlation between that the different columns have to each other, but we've already dropped one of the columns, so everything should be pretty good. So now what we want to do is we want to define our X and our Y values. So your Y is combi.medium house value values, and your X is combi drop medium house value, axis equals 1. And then what we're going to do is we're going to normalize it. And when we normalize it, what we do is we make all of the values, well, all of the cells to be a value between 0 and 1, because it's easier for the model to make predictions on values if they're close together. And so now what we're going to do is we're going to use sklearn's train test split to split the data set up into training and validation sets. And you can see we only have 4 features now. So that's interesting. We started out with 9 features. And yeah, we started out with 9 features. And then we're really 8 features in the label. And now we only have 4 features in the label after we have deleted the features that this instructor asked to be deleted, and then we also deleted the features in accordance with that formula. So now we're going to define model. We're going to use sklearn's linear regression because that's what the instructor wanted. And with this linear regression, we only have 46% accuracy. And the reason why that we only have 46% accuracy is because we have dropped several features, which is primarily due to what the instructor wanted to be dropped. We make predictions on the validation set, and you only get 46% accuracy on that. We check our RMS, that's your error. You have an error of 71,640. And then we plot it. And then when we plot it, you can see that there is a disparity between the actual values and the predicted values. And then so you've got a little data frame here where you can see the actual values as opposed to the predicted values. So now what we're going to do is what this instructor had asked to be done was to be able to make predictions on individual features. And that's not normally what we do, but what I did was I set the data up so you can make a prediction on an individual feature. So x1 equals combi housing median age dot values dot reshape -1 1. x2 equals combi total rooms dot values reshape -1 1. x3 equals combi median income dot values dot reshape dot -1 1. And y equals combi median house values dot reshape. And we're going to normalize x1, x2, x3, and we're going to use the same formula that we had previously used to normalize combi. And now what we're going to do is, instead of using train test split to split the variables up between training and validation sets, then what we're going to do is we're just going to manually split it up. So x train 1 equals x1 over to length x. Length x is 90% of combi converted to an integer. X train 2 is x2 length x. X train 3 is x3 0 to length x. X val 1 is x1 length x to the end. X val 2 is x2 length x to the end. X val 3 is x3 length x to the end. And then we're going to check y train 1 equals y 0 to length x, and y val 1 equals y length x to the end. And we're going to select the model, which is what the instructor wanted. And I experimented with all three of these features, and the feature that I'm going to use is the feature that gave me the highest accuracy, which was x train 3. So x train 3 is going to be median income. So what you're going to do is you're going to use linear regression to make predictions on the value of the house based upon the median income of the people who would buy that house. And so I made predictions on the validation set for x3, and you had a 39% accuracy. And then we checked our RMS value. So your RMS value is 75897. So let's come back here, and the RMS value for the entire data training set was 71640. So the error for the entire training set is better than the error that you would receive for only one feature. And then we plotted that out so you can see that this is a comparison of the predicted values against the actual values, and you can see that it's not as good as the first one. So what I wanted to do here, because I was thinking about this, I want to go back, and this where it drops the columns, I want to change it. I want to change it to 99 so it doesn't drop a column. And I want to see what the accuracy is when it doesn't drop that one column. And we've only dropped the column that the instructor asked to be dropped. So when we didn't drop the column, we had a higher accuracy. So when you drop the column, that reduces your accuracy. So without that column dropped, you had a 68,127 error. And then when you tested only one feature, you had a 75,897 error. So what that is doing is that is telling you that the model has a better accuracy if you use all of the features except for the ones that the instructor asked to be dropped. So this is that homework assignment. I only did it on X3, but the person that asked for this, he can do it on X1 and X2 himself. I'm not prepared to give out my Jupyter notebook because that's cheating, because basically the likelihood of this person taking my Jupyter notebook and handing it in, pretending that it's his work, is very high. But I will do a code review or a homework review and just give him some insight on what I did and how I did it. And I personally can't say that this is what the instructor wanted because I've never done this before, but that's how I would do it. So this is the homework review. I hope you got some information on the few little bits and pieces that I showed you how to do. So I showed you how to split the training set up for training and validating the way that I would do it. We did it with sklearn, and then we also did it manually. And I showed you a few other little pieces of information that hopefully it will help you with your programming and with your homework assignments. So I'm going to go ahead and close this video for now. I hope you got some insight into it and you got some information on how to do what the instructor wants you to do. And thank you so much for supporting my channel. If you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future.